number 7. Number 7 is kind of the same type of problem. You have to kind of sort through things. The only thing that's going to be a little irritating, excuse me, is that if you look at the X, Y, Z axis, X, Y, Z, here's my X, here's my Y, here's my Z, okay? You're saying that the point travels parallel to this purple one. So how far is it moving in the X direction? 0. How about the Y direction? 0. So the direction vector is going to be 0, 0, and then I don't know where it's going. We'll just call it 1. If you put a 2 there, 3 there, 4 there, it doesn't matter. Just 1 is good enough. That's my direction vector. So now it says, write down the equation of L1. So L1 is going to be X, Y, Z. Do we know the point for this one? A point that it goes through? Yep, 810. Did you have 9 in yours? On yours? Okay. And then this is 001. And just for future reference, the 3 parametrics are going to be X equal to 8 plus 0, Y is equal to 1 plus 0, and Z is equal to 0 plus T. This is the parametric that you're going to need to know. Write these down if you didn't get them. Line 2 has an equation. Whenever you see R, you can change it into what? X, Y, Z. Yep. And let's see. Show that A lies in L2. Well, let's do this first. I'm going to put the parametric for this one, X equal to 2 plus 2S. Y is equal to 4 minus S, and Z is equal to negative 1 plus 5S. So these are parametrics as well. All right, now they're saying that this point A, you're going to prove that this point A is on this line. So let's put 629 equal to 2, 4, negative 1 plus S times 2, negative 1, 5. Now what S should be should make it true for all 3 of these. So what would S have to be to make 6 equal to 2 plus how many times 2? 2 plus what is 6? 4, so 4 divided by 2. S should be 2 for this to work. Well, it has to work for the next one, too. Is 2 equal to 4 minus 2? Is 9 equal to negative 1 plus 10? Yes, so S is true for all X, Y, Z. Therefore, it's on the point is on there. We showed that. Point of intersection. Oh, your favorite thing. How many of you don't know how to do intersections yet? Oh, good. All you have to do is set the x's equal to each other. So set x equal to x. So up here we have x equal to 8, and we have x equal to 2 plus 2s. So 8 should be equal to 2 plus 2s. And so 8 minus 2 is 6. What would s have to be? 3. Yeah. All right, let's try it for the next one. Y is equal to 1, and y is equal to 4 minus s. So if y is equal to y, then, oh, I can't remember what that was. 1 is equal to 4 minus s. So s plus 1 equals 4. Oh, s is equal to 3 again. So what does this tell me? That it's going to work. And you could check that. You could check it for Z, but you're going to be good for that. So, what's that? Okay. It should be the same S. Then, to find the intersection, quiet please, guys. Then all we should have to do then is if S is equal to 3, just put a 3 in for this. And so if S is equal to 3, you're going to get 2 plus 6 is 8. 4 minus 3 is 1. Negative 1 plus 15 is 14. So I get an intersection of 8, 1, 14. Huh, good for me. I got it. Then it says find AB if A back here is 810. Well, that's P. Where's A? This is A. Here's A right here. So let's get a red going here. A is equal to 6, 2, 9, and B, the intersection, right? B is the intersection. So B is equal to 8, 1, 14. You should be able to find AB now. And AB is going to be 8 minus 6 is 2. 1 minus 2 is negative 1. 14 minus 9 is negative 5. Positive 5. How's that? There's AB. Now we're ready for the part that isn't on my slide, but you said find point C, right? That makes a parallelogram. Is that A, B, C, D? Is that right? Okay. So let's make a parallelogram. A, B, C, and D. A has a point of 6, 2, 9. 6, 2, 9. B has a point 8, 1, 14. And we got to know C. Did they give us C? Where's C? Oh, it's on D. Okay, so what does C say? 2, 1, negative 1. All right? 4. And so now we want to find out what D is. Everybody okay with that? Once you draw it this way, what are you adding here? 8 minus 2, right? 1 plus 1. 14 to get to 9 minus 5. So if you do that here, minus 2 plus 1 minus 5, you should be able to get D. 2 minus 2 is 0. 1 minus 1 is 0. Negative 4 plus 5, right? Did I do these right? Was I? No. I'm sorry. We're adding these, aren't we? Because we went 8 plus negative 2 to get 6. 2 minus 2 is 0. 1 plus 1 is 2. Negative 4 plus negative 5 is negative 9. And that is correct for D. 0, 2, what's that? Okay, so what I did is I made the parallelogram like that. These are parallel. They have the same vector to them. These will be parallel. So this vector has to be the same as this vector. So if I subtract 2 to get this, add 1, subtract 5, I got to do the same thing here to get this. A little tricky. And that's number 7. What'd you